Hi folks, just having another go at the example that we did today. I'm going to try and break it down into some clear steps to make it a little bit simpler and look at some different ways that we can find all of the solutions. So when we're solving trigonometric equations or circular functions, I recommend the first thing that you do is number one, rearrange your equation. And when we rearrange the equation, we're going to get the sine or the cosine or the tan part by itself. So in this case, I'm going to move the root 3 on 2 to the other side of the equal sign, which gives me sine of 2x equals root 3 on 2. Okay. Second thing I do is I find my reference angle. So reference angle. This is where I use the exact values table, and I'm going to find out what the angle is for sine that equals root 3 on 2. And sine of root 3 on 2 is when we have an angle of pi on 3 radians. So that's my reference angle. That's my solution in the first quadrant. Okay, so I know that everything's going to be related to pi on 3 now. Okay, step 3. I always now draw my unit circle. Okay, so unit circle, and very quickly I'm going to draw where all of my solutions lie. So in this case, we have got that solution in the first quadrant. That is one point where sine equals root 3 on 2. And it's helpful to just know that root 3 on 2 is approximately 0.9. So we're saying, when is the vertical distance 0.9? There's actually two places that happens in my unit circle, and I've just drawn them here. So the first one is pi on 3. And my second one will be 2 pi on 3. And I'll draw it on the outside because that's just makes the inside a little less messy. Okay, so there's my two angles that I'm going to work with. They're my first two initial solutions. So now I want to find all solutions. Find all solutions in the given domain. Alright, so all solutions within the given domain. In this question, I didn't have it up the top. I forgot to write it down, but in this question when we did it in class, we were told that my solutions needed to be between 2 pi, negative 2 pi, and 2 pi. So what does that mean? That means, well, my x values have to be greater than negative 2 pi and less than 2 pi. Now these two solutions up here, these have been based entirely on my reference angle of theta. But I don't want theta. I'm trying to find out what x is. And in my equation, it's actually 2x. So a trick here is I'm going to change my solutions for x. I'm going to find out what is the domain that 2x has to be between. Now if x is between negative 2 pi and 2 pi, then 2x will be between negative 4 pi and 4 pi. So now I have my first two solutions. My first two solutions, we've got them there at pi on 3, 2 pi on 3. What I'm going to do now to find my other solutions, because we can go around the unit circle multiple times, what I'm going to do to find my other solutions is I'm going to take that answer of pi on 3 and I'm going to add one full revolution of the unit circle to it. And then I'm going to take my solution of 2 pi on 3 and add one full revolution of the unit circle to it. So now these solutions come from the first lap of the unit circle, and these solutions are when I have gone round the unit circle more than once. Okay, now that's only going in the positive direction. If we were at pi on 3 and we took away 2 pi, we went backwards around the unit circle, I would get another solution. So let's do that one now. Let's do pi on 3 and take away 2 pi. Let's do 2 pi on 3, take away 2 pi. And what we start to do is create all of our solutions. Let's do a little bit of simplifying here. 2 pi on 3. 2 pi plus pi on 3 is equal to 7 pi on 3. 2 pi on 3 plus 2 pi is 8 pi on 3. Go in the other direction, it'll be minus 5 pi on 3. 2 pi on 3 minus 2 pi will be minus 4 pi on 3. And we've got some more solutions. Let's look at what happens if we get the next solution. What if we had pi on 3 plus 2 laps of the unit circle? 4 pi. That would give me an answer of 13 pi on 3, which is also greater than 4 pi. So this number is actually bigger than what I needed up here. So I don't need to worry about that solution. It's not within the set domain. Let's have a look at the other direction though. What if I had the pi on 3 answer and I took away 4 pi? Well, minus 4 pi is minus 12 pi on 3, which gives me an answer of minus 11. That's not an 11. Gives me an answer of minus 11 pi on 3. Now 11 pi on 3, that is bigger than negative 4 pi. So that is within my domain. I need to include that answer as well. Rub that out, just because I've got a bit too much going on. So this answer was actually minus 11 pi on 3. Let's try again for my other one. What if I had minus 5 pi on 3, take away 4 pi? That equals, sorry, it wasn't minus 5 pi on 3. I got the wrong number there. What if I had 2 pi on 3, take away 4 pi? 2 pi on 3, take away 4 pi. That becomes 2 pi on 3, take away 12 pi on 3, which equals minus 10 pi on 3. That's also within my range. That is also bigger than negative 4 pi. So I've got to include that one. Negative 10 pi on 3. And if I keep adding and subtracting 2 pi to these numbers, or I keep going around my unit circle, I'll get a whole heap of answers. And what I have to keep checking back are my answers between the domain that's been set. These are all my answers for 2x. We don't want to find 2x, we want to find out what x is. So the easiest way to manage this is, because we're working in fractions here on the left-hand side, rather than dividing by 2, the way I'm going to undo the 2, the way I'm going to work backwards is I'm not going to divide by 2. Not wrong, but what I like to do is actually multiply both sides by 1/2. So if I multiply 2x by 1/2, I get x. And my reason for choosing to multiply by 1/2 is all of these fractions on the left-hand side are really easy to multiply by 1/2. And you can see the pattern, the consistency here. I always end up with just a denominator of 6. And you can write it all out in one step and then simplify your fractions, or you can simplify as you go along. That'll be negative 5 pi on 3. Negative 11 pi on 6 can't be simplified. Negative 2 pi on 3. Negative 5 pi on 6 can't be simplified. And we get all of my answers. 2 pi on 6 can be simplified. And 8 pi on 3 can be simplified. And now they are all my answers for x, and all of my answers are at the end, fit within this original domain of 0 to 2 pi. Okay, take some practice. So have a crack at some questions, make some mistakes. Mistakes are where we learn. Look for patterns. There are lots of shortcuts that you can take, and you will get stacks better at managing these fractions with pi on 3s and pi on 6s and pi on 4s when you start using them. If you keep going back to using degrees for your angles, you're never going to practice the fraction skills to become more efficient at it. Okay, thank you.